The first couple of slides that I had were just stuff that you did from the first test. So basically, exam 1 talked about closed systems, right? So I used the water bottle analogy, or the piston cylinder, or what have you. And so you have some sort of substance inside of it, and typically when we looked at the first law, you had the first law was something like the change in energy is equal to the change in internal energy plus change in kinetic energy plus change in potential energy. And if you recall, this from physics is what you did with Dr. Wick in physics, and typically in the problems that you see in thermo, you just neglect these, right? And so if you look at this water bottle, if this water bottle, if I'm calling this my datum point here, right, and the water bottle is sitting on this table, then therefore the potential energy is 0, right? And the kinetic energy has something to do with the speed at which this system is moving around. So if the system is sitting on the table flat, then it's not moving, and therefore we just neglect that, right? And so that's typically how you can kind of, I guess, think about when you make these go to 0 or you neglect them, you can kind of think about that example. Another thing that you did was you used the steam tables and you used the ideal gas law to find different property values. You also used the PV diagram, and depending upon what substance you had, this was called the two-phase region, right? You had this thing called like the quality, right? You had something called max the quality, right? Which meant that you had a mixture of gas and liquid in the same or at the same time, and anything out here was like superheated, right? And anything to the left of this curve was like compressed liquid, right? And so any of the problems that you did, you looked at the tables, the corresponding table, and you found the properties to solve the problem, right? So that's what you did there.
So are we going to need that table for exam 2?
Yes, and you're going to need it for the control volume problems. And I'm going to do an example of that today. All right. Another thing that you guys did was use the principle of corresponding states if the gas wasn't ideal, right? I'm sure you guys had a problem, right? Now, in this exam, you're not going to have to do principle of corresponding states. Typically, what she'll give is she'll give an ideal gas law problem, okay, in terms of the Carnot cycle. Or the Carnot cycle could be like liquid, like water. And if it's water, then you've got to use the steam tables, right? And then in terms of the control volume problems, it will either be an ideal gas or it will be some other sort of substance where you use the steam table. So there's no principle of corresponding states. It's just ideal gas law, if that applies, or the steam tables. All right? So that should be able to narrow it down for you in terms of this test. All right, so let me just summarize here what the two types of problems are going to be. And again, this is all in the PowerPoint, so I'll just do it generally here and then you can look at it later. So the first type, and I just call it type 1, is going to be, I think I just make sure I do the right order here, control volume problems. And specifically, they're going to be at steady state. And I'll show you, or remind you, I guess, what that means. Alright, so what I mean by at steady state, that means that when you write the energy equation for the control volume, the system is not changing in time, right? So the dE dt kind of term, remember this from the first law, is equal to 0. All right, and so basically what you're doing is when you do this analysis on the exam, you're not looking at what happens at the beginning or the end, right? You're just looking at what happens when the system is at steady state. And I believe for the homework there was a problem or two where you had to do a unsteady state analysis. Don't worry about that for the exam. All right, so everything on the exam is steady state. Another thing that you're going to want to get familiar with is different types of control volume equipment, right? If it's a nozzle, if it's a diffuser, if it's a air exchanger, if it's a turbine, all of those have specific, I guess, properties that you can use to apply when you use the energy equation. Like, for example, a turbine is going to produce power, right? So when you see this term in the energy equation, right, if you have a turbine in the problem, then this is going to be a positive value, right, because it's producing power, right? If you have a pump, you need power to power the pump to do something else, right? So then this would be negative if it's a pump, right? And so sometimes, it's not going to be stated in the problem whether or not it's positive or negative. You're going to have to apply that. So go back to your class notes, the textbook, it's in the book, and on your note card, just write down, whether or not this is positive or negative, or, for example, for an air exchanger, this is 0, right? Because it doesn't do any work, right? There's no power generated to it. Or for a nozzle, this is 0 because there's no work done by the nozzle. Right? There's no electrical power. Like you're not plugging it into something, right? All right. So just go back and summarize that. Put that on your note card. Okay, that's fine. The second type of problem is the Carnot cycle. Basically, you got to watch what the substance is, right? So the substance type, depending upon what it is, whether it's a gas or whether it's a two-phase substance region, you're going to have to draw a different PV diagram. And I'm actually going to draw both of them on the board so you can write it down, put it on your note card. You're going to have to write it small on your note card. But if you write that on your note card with the numbering system, then solving the problem should be easy when you get to the exam, right? So I'll draw that. So let's look at, I'm going to first just look at the PV diagrams for the Carnot cycles, the two different cases. All right, and so if I have, let's say water, obviously I've got to use the steam tables.
So, quick question.
Mm-hmm.
So the only time you don't have to use the steam table is when it's not water, right?
Yeah, like if it's a gas, that's ideal, right? And I think she'll say, like, if she says air, she'll say ideal. And then therefore you use ideal gas law, then you're going to use the ideal gas law table.
All right.
All right, so it's like table
Oh,
23
okay.
or whatever. If it's not water, it could be ammonia, it could be, something else, right? But you're going to use the steam tables. It will be a substance in the steam tables, right? All right, so don't get hung up on whether or not it's water or, it could be anything, right? All right, so